All right, we're going to finish up chapter 4 here with a discussion of the real number system. Now that we've talked about roots, square roots, and cube roots, we can talk about other types of numbers now that we get when we take square roots of numbers, and those are irrational numbers. So if you'll remember the rational numbers that we talked about last chapter, that was any number that can be written as a fraction. Well, an irrational number is any number that cannot be written as a fraction. And we talked about it briefly in chapter 3, but now we're going to talk about it in a little more detail. So when we put the rational numbers together with the irrational numbers, we get a number system called the real numbers. And that's the set of all rational and irrational numbers. So just to review, what are irrational numbers? Well, last chapter we learned that they were non-terminating, non-repeating decimals. Decimals that never terminate or repeat are irrational. And now we can add to that square roots of non-perfect squares. So if you take the square root of something that's not a perfect square, you're going to get a non-terminating, non-repeating decimal. So therefore, you're going to get an irrational number. So that's why we talk about this now after we've talked about square roots. So just to review, you remember this guy. We talked about the number system last chapter and how we get our natural or our counting numbers, those first numbers that you ever learned when you were a wee little bitty baby, 1, 2, 3, 4, 5, so on and so forth. Those were the counting numbers or the natural numbers. And then we expanded the natural numbers to include 0. And then we have the whole numbers. And then we talked about opposites of whole numbers. So negative numbers, negative whole numbers, those were the integers. So we have positive and negative whole numbers are the integers. And then we have the fractions and decimals, both terminating and repeating, to round out the rational numbers. So now we're going to tag on another little section here in this rectangular portion here called the irrational numbers. And we did talk about a few of them last chapter. Namely, we talked about pi, that number that never ends and never repeats. That's an irrational number. And we also talked about the decimal 0.123456789101213, so on and so forth. That number will never end and never repeat. So that's an irrational number. Now we're going to throw in numbers like this, the square root of 17. Well, 17 is not a perfect square. 16 is and 25 is, but 17 is not. So if you take the square root of 17, you're going to get a non-terminating, non-repeating decimal. Therefore, the square root of 17 is an irrational number. And then another decimal there is 0.1011001111000. Again, that pattern will never terminate or repeat. And then another example of a square root of a non-perfect square, the square root of 3. 3 is not a perfect square, so the square root of 3 will be an irrational number. That will give you a non-terminating, non-repeating decimal. So together with the numbers that we learned last chapter and then these types of numbers, we get the real numbers. So everything on this page is considered a real number. Both the rational and the irrational numbers together. So let's see, what sets do these numbers belong to? So we've got various number representations here, and we're going to categorize them into the sets into which they belong. So 0.7 or 7/10. Well, that is not a natural number. That's not a counting number. It's also not a counting number or 0, so it's not a whole number. It's also not an integer. It's not a whole number or its opposite, but it is rational. We can write that as a fraction, namely 7/10. So it is rational. So if it is rational, then it's not going to be irrational. It can't be both rational and irrational. So it's only a rational number. That's the only set to which it belongs. The next one, 9/5. That is 1 4/5. That's not a natural number. That's not a counting number. It's not a whole number. It's not an integer, but it is rational because it is written as a fraction. And then that means it is not irrational. The next one, the square root of 100. Well, the square root of 100 is 10. So 10 is categorized as a natural number. That's a counting number. It's also a whole number. It's also an integer. And it's also rational. We can write that as a fraction, 10 over 1 or 20 over 2. And therefore, then it is not irrational. The next one in the next column, 5.3 repeating. This is a repeating decimal, so we can write it as a fraction, 5 1/3 or 16 thirds. It's not natural. It's not a whole number. It's not an integer, but it is rational. The next one, the square root of 15. Well, 15 is not a perfect square. 16 is, but 15 isn't. So the square root of a non-perfect square, that's going to make that an irrational number. That's going to give us a decimal that is going to be 3 point something, but that's going to be non-terminating and non-repeating. And then the last one, -6, that's not a natural or a counting number. It's not a whole number. It is an integer, and it is rational as well. Therefore, it is not irrational. So that's just categorizing numbers based on what sets they belong to. And then finally, we're going to talk about solving some equations using our roots. So using roots to solve equations, we're going to get some irrational numbers when we do this. So we're going to talk about this here in this last section. So in the blue box here, I've got a couple of statements here. If x squared is equal to y, then x is equal to the positive or negative square root of y. So remember, a square root has two square roots, a positive and a negative. So when we're trying to find out a square root, we're going to have to include both roots. So we can use the square root to solve an equation like that. And then likewise, if x cubed equals y, then x is equal to the cubed root of y. We would just find the cubed root of y, and that would tell me what x is. And then again, if y is positive, then x is going to be positive. If y is negative, then x is going to be negative in those cubed root cases. So let's look at a couple examples here. If x squared equals 38, what is x? Well, to find out what x is, we would have to take the square root of 38. Remember, powers and roots are opposite operations. So to undo the squaring of x, we would have to take the square root. So we would take the square root of 38, but again, we're going to include the positive and the negative square root of 38. And the only way to figure that out, besides guess and check, is to type it into your calculator. And if you type this into the calculator, 38 is not a perfect square. So you're going to get a non-terminating, non-repeating decimal. So we're just going to round that to the nearest tenth. And so we get x is approximately positive or negative 6.2, because 6.2 squared and negative 6.2 squared is going to get you about to 38. Next one, a to the third power is 125, or a cubed is 125. So to find out what a is, to solve this equation, we would take the cubed root of 125 to find out what a is. And again, if you type that into your calculator, or if you have that one memorized, you know that the cubed root of 125 is 5. So a equals 5 in that case. It's not positive or negative, because a positive cube, the cube root of a positive number is going to be positive, and the cube root of a negative number is going to be negative. Next one is a little bit different. 3 times d squared equals 363. This one's going to take an extra step to solve, because I just want to get d squared. I just want to know what d squared is. But if I take d squared times 3, I get 363. So that means that d squared has to be 121, or in other words, 363 divided by 3. So I know that d squared is 121 because 121 times 3 is 363. And then once I get d squared alone, I need to figure out what d is by taking the square root of 121. And again, square roots have two possible answers, the positive and the negative. So the square root of 121 is 11. So d is positive or negative 11. So let's take a look at a few more, and let's solve these. 729 is equal to s cubed. So to solve this equation, we're going to have to take the cubed root of 729, and that's going to tell me what s is. And again, if you type that into your calculator, probably don't have that one memorized. The cubed root of 729 is 9, so s equals 9, and we've solved that equation. And then if we wanted to check that, we can just type that in. 9 to the third power is indeed 729. That checks out. So we know that s is 9. Next one, 4 times n squared is 100. Well, I just want to know what n squared is. So 4 times what would give me 100? Well, 100 divided by 4 is 25. So I know n squared has to equal 25. So if I want to find out what n is, I'm going to have to find the square root of 25. And again, that's going to be the positive or the negative square root of 125 because we've got two possibilities here. And that means n is positive or negative 5. Two solutions to this equation because 5 squared is 25 and 25 times 4 then is 100, and negative 5 squared is 25 and 25 times 4 is 100. So there are actually two solutions to this equation, positive and negative 5. And then the last one, x cubed equals 512. Again, to solve this, I'm going to have to take the cubed root of 512. And if you type that in your calculator or if you have that memorized, x is 8. And I know that's true because if I type 8 to the third power is 512. So I know x is 8. So classifying these numbers in the real number system, the set of rational numbers and irrational numbers together is the real number system, and then solving some more unique equations maybe that you haven't seen before using the roots that we've just learned.